All right, we're up and running here. We're going to talk a little bit about polymers, two different videos because there's a couple different types of polymers. Let's do a brief intro as to what a polymer is. The name has two parts. I'm not sure if it's Greek or Latin, but it's some old language. Poly means many, and mer means parts. So these are molecules with many parts. They are huge molecules made up of many repeating units. These repeating units are called monomers. These are the little things that make up the big thing. Some examples in our daily life: proteins are polymers of amino acids. DNA is a protein of nucleic acids. Carbs are proteins of sugar molecules. Teflon is a protein of it's a type of amine. Nylon is a protein is a polymer. There's two types of polymers. They are formed, the first type are called addition polymers, and they are called addition polymers for a reason, because they are formed by addition reactions. Now, if you think about it, if I have some molecule that's happy, and now I need some molecule that suddenly wants to make not one bond, but two bonds, if we're going to make a chain of them. If I think about what's got to be inside here, they probably have to have a multiple bond. And if I can break that, let's say C double bond C, if I break that guy, then this thing is now willing to look like this and make two other bonds. There's a few steps to addition polymerization. First stage is initiation. You need something that's going to get this reaction started. Usually you start with a peroxide, a very common one being hydrogen peroxide, which is H2O2. It's O attached to an O attached to an H attached to an H. This O bond O will break, and I will be left with two OR molecules, and O is only making one bond, so it has an electron here that's not being used in bonding. It's called a free radical, and this guy is desperate to react with something. And that's why I need them, because they are going to perform the operation of getting this reaction started. So I got a bunch of these in the container. Here it is. And I drop in, let's the simplest thing with a multiple bond, ethene. I drop in some ethene. This unpaired electron will see these four electrons in here as a juicy place to go. It will move in, it will break the double bond, and there it is. It will attach, but then this carbon will not be happy. It will have an unpaired electron. And here I've redrawn this molecule. I've redrawn it right down here. So I've redrawn this right here. And it finds another ethene molecule, and the same process happens. Double bond is broken, attaches on, there it is. Now there's four carbons in a row here, and still an electron on the end. And it will continue, this process will continue. As long as I keep pumping in ethane, keep the conditions right. Until the last stage happens, termination, where I've got a long chain like this, and I've got another identical long chain, or maybe not identical, but another long chain of carbons. Both of them have an unpaired electron, and they will meet and fall in love and form a bond here, and I will get one big molecule at the end. Now, some people are sitting here thinking, well, wait a second, there's an O on the end and an R. Yeah, there's an O on the end, and O and R here, and there's an O R here. But when I put thousands of these ethene molecules together, this and this sticking on the ends of 1,000 carbon molecules doesn't mean much. They become insignificant. these things become insignificant over time as the molecule grows and grows. Some common polymers that are addition polymers, I made a little chart here. When I have ethene as my monomer, I make polyethene, and we use that in plastic bags. If I have this molecule called styrene, that's a benzene ring here, or a phenyl group, I get something called polystyrene, and we call it styrofoam. If I use this thing called vinyl chloride, it's a chlorine molecule on ethene. When I put a bunch of these together, I get polyvinyl chloride, or PVC. We use this in plastic plumbing pipes. In North America, they're usually black in color, but in other parts of the world, you might see them as white when you're poking around in your basement. And last point here, addition polymers can be several 100,000 monomers long, with molar masses bigger than 1,000,000. So these things can get huge. The other type, not quite as big, but these guys, addition polymers, can get huge. So that's our initial look on at addition polymers and what polymers are in general.